Hello and welcome. Thank you for joining us today. It's been a great summit. I hope you had insightful sessions today. But there's one more to go, last session of the day. I'm here for a very special guest, Aaron Balcon, from one of our customers, Candid. He's going to share with us a very interesting scenario where he's interacting with data lakes using AWS AppSync. I am Ed Lima, a senior solutions architect with the AppSync and Amplify team. I relocated from Australia a couple of months ago to the US. I've been at AWS for a couple of years, and I changed the Australian summer to beautiful Seattle summer. It's not as warm as it used to be. It's great to be here at New York City. It's my first time presenting at the New York City Summit. I'm very excited. And we're here to talk about next generation intelligent data lakes with GraphQL and AWS AppSync. So what we're going to be talking today is our agenda. We're going to be talking about data and APIs and how they are closely related to each other. We're going to be talking about GraphQL, which is a very powerful and flexible API to query data. I'd like a show of hands. How many people use GraphQL here? A few? OK. So we're going to be giving a little introduction on GraphQL for the people who don't know it. We're also going to be talking about AppSync and a couple of use cases and scenarios where AppSync is being used in production. And finally, Aaron's going to share with us his great use case on using AppSync to interact with data lakes. So let's get started. First of all, let's start with data. Data really powers everything that we do. If you have a business, if you have an application, you need to be able to get insights from data. And I really like the top quote there, because you can have lots of data, but if you don't know how to reason with that data, then you're not making good use, you're not getting insights, you're not getting answers. And that's an important thing, that's an important value that data provides, answers. Answers to questions from different personas. Those personas could be business analysts, a CTO or CEO, or data scientists. And each one of those personas, they need to access the same data, but they need to view in different ways, so maybe different views of the data. We also used to be in a world where everything was relational. So all the databases that we had were SQL databases. But that's not the case anymore. Our CTO, Werner Vogels, he mentioned in one of the great articles, one size fits all database doesn't fit anyone. And I totally agree with that. I'm a big fan of using the best tool for the job. You don't build a house with just a hammer. But of course, there are also lots of options. You have time stream databases, you have ledger databases, you have graph databases, you have SQL, NoSQL. You can implement all those sorts of tools, very powerful tools to store your data in AWS. And of course, we also have the database that you might have on premises, right? Running on data centers. You can also connect to those and bring that data to AWS. However, in order to manage those databases, you need expertise. You need people that are experts in SQL, experts in time stream databases, in graph databases, in ledger databases, right? It would be great to have a common language where you can interact with all those databases. And those are APIs. Application programming interfaces allows us to our applications to interact with other services, microservices, or external APIs. and interconnect and interact and reason with data from those different services. This is a basic API technology stack. A friend of mine, he likes to call it the new 3-tier architecture of modern days. So of course you have your data on the back end. You have an API backend where you can add some business logic, and the API, which is the front door where your clients are connecting to your data. And of course, you can expand this use case and make it more complex with failover capability, load balancers, adding specific application servers, message buses, and workers. I like to make an analogy with a restaurant. So imagine you and your friends are going to a restaurant, right? Of course, every restaurant is different. Maybe you're feeling like having Italian or going to a steakhouse. As soon as you get to a restaurant, you then need to get the food menu from a waiter or waitress. And that waiter or waitress is going to give you the options or maybe tell you about the specials. Once you have those options, the waiter is going to be the interface between the client and the kitchen. In the kitchen, we have a cook that's going to prepare the meal. And of course, the meal is prepared using ingredients, right? And those ingredients, the cook is an expert on those ingredients. He knows how to extract the flavors, right? And me and my friends who don't know how to cook, we have no idea on how to do what the cook is doing for us. So you can bring that analogy to APIs. So you can think of the ingredients as your raw data on your different data sources or databases. An API backend is the cook, which is interacting with that data and is actually preparing the meal to be served by the waiter or waitress, which is the API. And of course, those personas, me and my friends, they're the different personas, right? Maybe I'm a vegan, so I'm ordering a vegetarian meal. Maybe my other friend, wearing glasses, wants a steak, right? Or maybe my other friend she's a data scientist, and she wants to get a different type of meal. So those are different personas. You get different meals according to the menu. And that's exactly how you need to view APIs and data. So taking that back to AWS, you can use that generic stack, and you can bring it to AWS. Of course, in AWS, you can take advantage of cloud-native features, such as availability zones, auto-scaling, and you still can add all those other capabilities, such as failover, load balancers, web and application servers, message buses, and workers. This is great, so it provides lots of flexibility. But also lots of management. You need to manage those API servers. You need to manage those API backend servers. You need to manage load balancers and all of that. So it's lots of operational heavy lifting. If you're using serverless, it means that I don't have to deal with that. Also, failover, high availability, and fault tolerance, scalability, it's all built in. And you only pay for what you use. Serverless is a great place to be because it allows me to focus on business logic, what differentiates my application, and not running that application stack, not running servers or managing servers, patching, monitoring, and all of that. And that's where you want to be. So you want to be in a future where all the code you ever write is business logic, because that allows you to move fast, to interact fast and add more features that are valuable to your business. And of course, you can bring all of that to our API technology stack. You can have serverless APIs, you can have serverless business logic, and if you want, you can also have serverless databases. And in that serverless world, you don't have to worry about lots of things. Web and application servers, load balancers, fault tolerance, but you can also add event buses, message buses, streams, workers. So it's still very flexible. But when you talk about APIs, there are different technologies, right? We have REST and GraphQL. REST is the golden standard for APIs. It's been around for 20 years. GraphQL was created in 2012, open source in 2015, and is an open standard. But what is GraphQL? I think an image basically shows better than words one of the main advantages of GraphQL. So let's imagine we have an application, here a blog post application, right? I have a post, so I need to make a call to get posts and populate my front end. So with REST, I make a call to a post endpoint. I get some post IDs. I use those IDs then to make a second call to get comments. But maybe I need to get details about authors, so I need to make 3 calls. So I had to make 3 calls, and in each one of those calls, I either received more data than I needed or less data than I needed. I was either overfetching or underfetching. With GraphQL, I make one single call, and I can access different data sources. Doesn't matter the technology, it's all abstracted by GraphQL, so you can have any sort of data source. A friend of mine, he likes to make an analogy with a pizza. So if you think about pizzas, when you're ordering a pizza, if you're doing it with REST, you're going to get a pizza with all the toppings, and you have to remove the toppings that you don't want. With GraphQL, you basically select the toppings that you want, and you only get what you requested. There's also a very interesting white paper I was reading the other day. So a group of researchers, they are working on a white paper. They wrote this white paper, and they demonstrated, they made an experiment. They converted 7 applications from REST to GraphQL. And they found out that the JSON payload that was returning, they were able to make a reduction in 94% in the fields that were returning, and 99% of the size of the JSON payloads. So GraphQL, it's a couple of years old, right? It was created around 7 years ago. And it's being a technology in high demand. The interest is growing a lot in GraphQL, and is very useful to transmit and manage data. And you can see here the popularity and the interest is growing a lot from developers, because it has all those capabilities that you make less network calls, you get all the data that you want. And there are lots of advantages as well. I'm not going to read all of them, but some of them, developer tooling, great documentation, performance, easy learning curve. So there are lots of advantages there in GraphQL. But what is GraphQL? It's a query language for APIs, and also a runtime to fulfill those queries. It's very important, GraphQL is not a graph database. You can connect a graph database to a GraphQL API, like we saw in our stack. But GraphQL is an API technology. It's basically, it allows you to define your data in a schema. So you have types. And here, an example, we have a user type. So you define fields of those types. There are properties, right? And you can also define multiple of those types in your schema, and operations. 3 types of operations: queries, mutations, and subscriptions. And there's a very interesting capability of GraphQL as well. It's called introspection. So you can make an introspection call to a GraphQL API, and you can retrieve your whole schema. If you think about back to our restaurant analogy, it's a very easy way to get the menu from our waiter and understand what format I need to make my calls. So GraphQL has three different operations: queries read data. Mutations is basically a write after a read. So basically, you're writing data, and then you retrieve the data that you just modified or updated. And finally, you have subscriptions. Subscriptions is a very powerful concept. They are linked to mutations, and they allow you to provide real-time notifications as soon as data changes on your backend. So GraphQL is great, but what's the best way to use GraphQL on AWS? If you want to manage servers and deal with all the undifferentiated heavy lifting, servers are sold 2014 anyway. That's why we released AWS AppSync. AWS AppSync allows you to build scalable applications on different data sources and also add built-in capabilities such as real-time and offline data access. So AppSync is a managed serverless GraphQL service. It allows us to connect to data sources in your own AWS account. And you can add real-time and offline capabilities very easily to your application. It also allows to be a GraphQL facade for any AWS service. You can add conflict resolution and detection on AppSync in the cloud, and you can also add different security mechanisms to authorize access to your API with IAM, Cognito, OpenID Connect, or API keys. And we have lots of customers using AppSync in production. So Public Good uses AppSync in their platform to connect news events with engagement activities and display relevant actions to news readers. IDT Telecom provides communication and payment services. It uses AppSync on cryptocurrency, peer-to-peer wallets, and money transfer processes. PureSec delivers end-to-end security solutions for serverless applications. It uses AppSync to provide customers with real-time updates on security of their serverless applications. Virgin Trains, they collect high-volume data from multiple real-time data sources, and AppSync delivers that data to commuters, to customers. And you have Aldo as an e-commerce solution, Ticketmaster also providing live information about venue data. CookPad uses AppSync and live cooking shows to provide engagement with chat applications and likes and things like that. So lots of different use cases. But how does AppSync work? So AppSync basically allows you to implement any sort of application, enterprise application, web, mobile applications, IoT applications. So when you back those applications, AppSync allows you to securely access and combine data from multiple data sources, databases, or APIs. So there are a couple of built-in support for specific data sources, Dynamo, Aurora Serverless, Elasticsearch, but you can connect to any other data source using AWS Lambda or HTTP resolvers. So HTTP resolvers allow you also to connect to REST APIs. You also have local pub-sub resolvers. It basically allows you to have a pub-sub interface where data is not persisted, but you have clients subscribe to that channel to receive data. So you have your apps, your client apps, you have your backend. All you need to do is define your data in a GraphQL schema. And then you use resolvers to link the data on your schema to the data sources. Maybe you have specific operations or types that are linked to a DynamoDB table, and other types are linked to an Aurora database. So resolvers provide the logic and the glue between the data sources and the GraphQL schema. AppSync uses resolvers with request templates. So request and response templates using VTL. So as soon as a client makes a call to a GraphQL API, a request template that's basically defined in VTL, you can add all sorts of logic to the call. You can add authorization checks, conflict resolution checks, add automatic IDs, and you can modify that call before it reaches the data source. The data source then sends a response, and you can also have a template to modify that response before it gets back to the client. We also have the concept of pipeline resolvers. So pipeline resolvers, they allow to link different resolvers in, if you think about orchestration, that you can link them in sequence, right? So you can make one single call and you can reach different data sources using resolver logic. Let's talk about new features that we released recently. One of them, multi-auth. So now you can define authentication in your GraphQL schema. Before, you only had a global authorization mode for the whole API, but now you can actually define a specific authorization method for types, for fields, for operations. So here, for instance, imagine I have some sort of application or API getting data from the backend, but I need to hide specific fields, right? So for instance, if I'm connecting with an API key, which is public access, I don't want people to see the email field. You can make a call, you still retrieve partial results, but the email comes as null. If I then authorize using a user directory, I authenticate my call using a user directory, and I make the exact same call, then I retrieve the email. So that's very powerful. It allows you to define security at the data definition level. We also integrated AppSync, release integration with CloudWatch login sites. We have specific sample queries that you can basically run on your CloudWatch login sites and get very valuable information about, for instance, most invoked resolvers, most invoked operations on your API, and also detect latency, for instance. So that's very useful to understand the behavior and the operation of the API, and also identify hotspots. Now let's move on and talk about some use cases and capabilities before we move on to our data lake use case. So one of those capabilities is very close to my heart because I also work in the product management team for real-time features on AppSync specifically. So you can use AppSync for real-time very easily, right? You can, for instance, have a backend service sending data to AppSync, performing a mutation, and since you can have clients subscribe to that mutation, you can broadcast data to thousands of clients or millions of clients. And it's very easy to use real-time with AppSync. Basically, AppSync allows to make any supported data source a real-time data source. The client just needs to make a subscription call. AppSync is going to return a WebSocket URL and a connection payload. And then the client is going to connect using the URL and the payload, and it's going to have a constant open WebSocket connection with AppSync. So that way you can receive real-time notifications. Also, fan out and scaling is all dealt by AppSync. So let's have a quick demo, right? A quick fun demo about real-time. And then we move on to a couple more use cases. If it can display my laptop screen. Let me try to unplug. Yeah, I'm sorry, folks. I think we're having some technical difficulties here. Yeah, it's not. Thank you. Thank you very much. You saved the demo. So this is the AppSync console, right? You can create your API. Also, you can import your API from Dynamo. So you can import a Dynamo table and it creates a GraphQL schema for you. So I have a database table with specific data. It detects my keys, and I can also add specific fields. So I just add this as a Notes app. And as you can see, it's going to really quickly create an API. And I can use GraphQL to interact with my API. So I can, for instance, create notes on my API. Okay, maybe there was an issue there. Let's try again. Okay, can create notes with my API, and I can list my notes. So as you notice, I'm not using DynamoDB, JSON, or anything like that. I'm just using GraphQL. And because GraphQL is very flexible, I can basically dictate what I want to see. For instance, I want to list just my email and the notes. And I just need to modify the definition of my client. So that's a quick overview on AppSync. But let's now move on to our fun demo. Fun real-time demo. So I have here, this is an app that was developed by one of our developer advocates, Nader Dabit. He's awesome. And basically, it uses an Amplify framework. With the Amplify framework, you can basically define a GraphQL schema, a very simple schema. It's going to expand and create a larger schema with some helper operations and CRUD logic. And I can deploy this to my Amplify console. So the Amplify console detects that I have Amplify console. I can connect to GitHub and allows me to create a full CI/CD pipeline. So every time I make a commit to my repo, it's going to basically trigger builds, right? I just need to define IAM role to link my console with my GitHub repository. And it's going to create an application and kick off a build. And you can see here it's going to start the whole process to provision, build, deploy, and then verify. And after that, it's going to host my application. It's a React application on CloudFront, or you can define your custom domain as well. As a good cooking show, I already had something here prepared because it's going to take about 5 minutes to deploy. So if you please be able to connect to this link on your phone, bit.ly/AppSync Summit. What you have here is a beatbox. So we're going to make some music together in real time. So demo gods, be kind. So again, bit.ly/AppSync Summit in one word. I created a drum machine. You can create other drum machines. Someone already did here. So if you open the drum machine, now you can start playing and interacting together. It's a bit too loud. And there you go, you're making music in real time, folks. That's a very fun demo. I love to show it. You could have thousands of people connecting and making music. And AppSync would deal with the whole real-time capability delivering that. Okay. That's great, but now let's move back to our slides. Of course, AppSync also allows to provide offline capabilities. So when the client goes offline, it allows you to interact with your application using our SDKs. And the client is smart enough to reconnect and send the data to AppSync as soon as the client reconnects. You can also have chat applications. You can have a fully serverless chat application, for instance, with DynamoDB, Cognito, storing your user data and having private chats, private rooms, private conversations. And it's all using real-time capabilities as well. Then you can start to think about more complex scenarios. And you have customers already doing this today, using AppSync for the connected cars platform. You could have connected cars sending telemetry to, AWS IoT. IoT then triggers a Lambda function that sends a mutation to AppSync. And you have a specific car owner receiving data about that car. So when you're using subscriptions, you can also have that ability to create specific IDs and send data to one client that's subscribed. AppSync can also be used in the backend. You can have AppSync interacting with multiple microservices. Maybe you have containers on your VPC, on ECS, on EKS. You can have Lambda interacting with those containers, using AppSync interacting with those containers using a Lambda resolver. Or you can have a service using a REST API. On API gateway, you can use HTTP resolvers. So you can have a single GraphQL API interacting with all those different microservices. And finally, more complex data use cases. So you can have GraphQL interacting with multiple data sources, SQL, NoSQL, graph. You can retrieve data from those data sources making one single API call. And here, to talk to an even more complex use case, we're about data lakes. It's my pleasure to invite Aaron to the stage and to talk about Data Fabric.
Great. Thanks, Ed. Appreciate the intro. So my name is Aaron Bauckham. I'm Candid's chief architect. So I'm that guy that when I was 14 years old, I started coding my first piece of code, making a computer do something, and it was so exhilarating, I've never stopped. I love solving really tough problems, especially for really large organizations that think that there's no way it's possible to be able to solve these types of problems. So those are the types of things that I get out of bed in the morning to actually really enjoy solving. So just a quick overview of this Data Fabric solution. We're going to talk a little bit about terminology, talk about the challenge of data, the managing data, and talk about what the ideal solution looks like, and then the Data Fabric capabilities that start to address those types of challenges. So from a terminology perspective, a data lake is a central repository for being able to store structured and unstructured data that exists within your organization. A data warehouse is that data integrated together and accessible by the organization. A data mart is usually a subset of that data warehouse that is designed for a specific line of business. A universal semantic layer is a representation for how you can, in a single let's say schema or a single type system, be able to address all the data that exists across an incredibly large enterprise. And an operational data lake is being able to take all that historical data that exists within your organization, but also combine real-time data within it to gain even more insights. Data provisioning is the concept of really treating data like a product, where it is tested, it has interfaces and integration that's built into the delivery of that data, and it is provisioned in a way such that there are tools and systems within the organization and users who can actually access it in a structured and governed way. Data promotion is the concept of data that is coming into the system that is promoted through several different stages, through layers of refinement, security, augmentation, aggregation, what's called wrangling, and that's a very specific promotion process, very similar to what you would find in a DevOps process for software development, but really geared towards data. Storage zones are the stages of that promotion process where data is stored through, and the storage zones are where that refinement and that landing zone or the security actually takes place. And last, data governance, ensuring that the right entitlements to the data are kept, ensuring that the right refinement and stewardship of that data is also taken care of as well. Now, data is everywhere. A lot of large organizations grow by acquisition, and when you acquire companies, they have data, and that data exists, and it has value, but accessing it can be difficult. There's different business units that have data, different geopolitical organizations, partners that exist that have that data, IoT systems. Data is really all across an organization. It's very, very difficult. Some think impossible to be able to have that represented in a single view. Now, because of those challenges, there's a lot of business loss associated with it. Here's some statistics that actually show that 12% of all the data that exists within organizations is actually accessible to everyone within the organization. And that there are some statistics that show that 40% of businesses believe that they lose business, they lose sales revenue because of inaccessibility of data that they have. They have it, it is within their ecosystem, but they cannot access it in an integrated and structured way to allow them to be able to solve their business challenges and problems. So the ideal solution is to have a single system that, from an operational perspective, is able to be able to provide help desk and workflow capabilities so that people know how data should be stewarded and how it should be refined throughout the process, providing a data catalog and data dictionaries that exist with search and lineage-based capabilities, having that universal semantic layer that exists within SQL, but also within an API. And that's where we're going to start talking about AppSync and its capabilities. Acquiring data into the system is a very big challenge, from databases, from both pulling data out of RDMS systems, but also having it pushed as well as streaming data that comes in, as well as file-based data that exists on enterprise file shares. And that promotion process, having that be a standardized, governed process that's very clear between environments. And last, governance, the policy, the security, and the entitlements that exist around that. So having that in a single platform is the ideal solution, and it's really tough to be able to get there. The Data Fabric solution makes these attempts to be able to start chipping away at that problem, providing a single solution for data acquisition, refinement, storage, and lineage, where the ability to acquire data out of these systems, to be able to wrangle that data. If you've input an address of a location and people type it in different, it's like, well, okay, I want to make sure that it's always this address of this form. So being able to have that type of normalization alignment within the data, being able to take advantage of all the cloud-native storage that Ed talked about earlier, that a single relational database is not always going to be the best way to access the data, that it may need to exist in lots of other types of storage systems. And then being able to provide the lineage that as data changes, as it progresses through the system, that it's very clear how it is changing as it progresses. Here's a high-level conceptual pattern being able to efficiently acquire data, large-scale data transformation governance was a big problem that we had, being able to provide an API into that data, and then being able to really address the problem of bad ETL code. A lot of organizations have tons of ELT and ETL code. I see lots of smiles in the audience because this is a well-known problem. So we really wanted to try to address that challenge, which, again, a lot of people think was actually impossible. So almost 2 years ago, when we had been following GraphQL pretty tight, and when AWS decided to come out with GraphQL as a service with AppSync, we were incredibly excited, and we said, you know what, this may be a really good opportunity to try to address some of these problems. So we came up with this solution to be able to do it. So here is an architecture that uses a generalized set of different types of data sources that exist, from real-time data that's being pushed in via file or via streaming, data that is pulled out of relational database systems or pushed. And what we did was try to standardize data types using GraphQL's innate capabilities to do that, to be able to use GraphQL's innate versioning capabilities of that data, being able to make data transformations functional in nature. Familiar with the concept of functional programming, there's a lot of advantages for debuggability, to make systems so that they are diagnosable, and to make ETL far more testable. That was a very, very big goal we had. So the big problem was, the first big set of problems was being able to acquire data out of relational database systems, out of API endpoints, and out of files and shared file services, and being able to acquire that data in a cost-effective way. If there's nothing changing in a source system, then I don't want to have to pay for servers to actually be able to continually keep pulling it out. From an operational perspective, if I have a problem acquiring data, I don't want it to be an incredibly laborious, challenging task to be able to diagnose what happened, what went wrong. I want it to be very clear and obvious what went wrong, being able to acquire data out of a system. And I need to be able to scale. If let's say my transaction load is about, let's say, 50 per second, except at midnight, where I suddenly get 10,000 per second when a lot of batch transaction happens from my partner organizations, I need to be able to effectively scale that out, process that load according to the cost structure that I want to be able to handle it without starving every other part of the system, and then scale back in. So being able to effectively scale is a really big problem as well. And then the flexibility of changing the types of source systems that I want to be able to acquire data from. The solution, we developed a YAML-based configuration that has a user interface in front of it to be able to describe the different types of data, the different types of data sources. We use Lambda excessively within the entire solution. If you look back at that architecture slide, Lambda is used in multiple places. Lambda is used as a controller, as a control plane for being able to coordinate work units that go into SQS queues. And then there are Lambda functions that actually process those queues. And they're smart. When let's say that a load of 1 million records suddenly hits the system, you don't want a Lambda function to suddenly process 1 million. The Lambda functions are smart to be able to split that into 5,000 record chunks, re-enqueue those back so that they end up being processed effectively and scaling out using the cloud natively for what it's intended to be able to do. Same thing with files. When files land on servers, being able to do the exact same thing, as well as streaming data. So that was our solution for those sets of problems. The next set of problems was large-scale data transformation governance. Within the source systems, we have a lot of bad source data that exists. There's inconsistencies in the data. It was difficult to change those source data systems in any way because of the nature of how they were being used. Its dependencies between teams and being able to change them was difficult. And those systems weren't able to scale as well. Imagine a workflow management system that has master data in it, but it wasn't meant for 1 million API requests to come to it because it's just a workflow system. So there was multiple challenges with source data systems and ETL dependency challenges. The fact that this ETL job had a dependency on this ETL job, and there was a lot of challenges with being able to handle that. So our solution is we created the concept of a data router, where we can define how to route data of particular types to what are called data processors. And this is a really key part of this entire architecture, is defining a data processor as 4 major capabilities. a execution engine, whether that be an ECS task, a Lambda function, or a glue job, an envelope. An envelope can either be an encrypted envelope or decrypted envelope, gzipped, a Parquet file, or an ORC file. The third property is the format. The format could be XML, could be JSON, CSV, EDI, or just text. And the last is the storage. Is the storage DynamoDB, Aurora, S3, or Redshift? So those are the four major components of a processor task. And the routes of that data are configured so that if data comes in of this type, that it goes to this data processor, and that data processor processes the data and outputs this type. And it was done through that entire architecture that we showed earlier. The next major problem was bad ETL code. So being able to transform data. If you've ever looked at ETL code, I've looked at source code files where there's tens of thousands of lines of massive amounts of SQL with huge joins and dependencies between each other. Heaven forbid if there's a problem in any part of that source code, because being able to debug and solve those types of problems is incredibly difficult. To being able to figure out the root cause analysis. And being able to support that from an engineering and operations perspective is another big challenge. So it's not only just the development, but also the operational aspect when all of a sudden massive queries hit and the servers aren't able to scale to the load that is actually hitting from a tolerant stack-up perspective. So the solution is to create a modernized ETL logic system using AppSync. So we created the concept of this meta-based type system that automates the creation of GraphQL schema. It automates the creation of resolvers to those cloud-native storage systems. We allow for the customization of resolvers to external data systems, which we'll show here in a second, and massively simplified the business logic of ETL. That was absolutely huge so that we could simplify debugging and have much higher quality ETL code that's much more supportable by the goal, less people. So what does that look like? So here's an example of AppSync at the core of addressing all this enterprise data that exists in cloud-native data stores as well as external systems. You see a call out to Salesforce or a call out to any other external system such as SAP. What I have here is an example of an ETL transformation rule. That rule has a name, and it's defined as this particular source data type, and when that changes, and that source can also be a scheduled job as well, that when that change happens, the extraction executes a standardized GraphQL query, but can use data based off the source, which you can see there, that source.productID, which is actually that source object that changed, to be able to query, let's say, an existing MySQL or Aurora server to be able to extract the data out. There's a transformation step, which here it's in JavaScript to be able to transform the data. This is a very simple example where it just says, okay, this data was updated, so I'm now going to overwrite the variables that were updated into my object of record, and then I'm going to load it. And this is really, it really showcases the big power of GraphQL and AppSync is that the load operation now allows me to take that transformation and to do anything with it. And exactly as Ed talked about before, and is what's shown here, I could update 5 different systems now with that change. And again, this is all happening within a serverless-based structure. Much easier to debug, much easier to diagnose, with far more traceability and much more testability of this particular code base. Because rules, ETL rules, can be designed like this, they're almost self-governing for development teams because they are now required to be able to support a standardized interface to data across the entire organization, which for the first time ever is possible. The last major problem was having a unified API for the organization. So the system that we were working with, different suppliers had different forms of EDI interfaces into the organization. There were different user portals for being able to order different types of products. There's different integrations that had different views of product master data. There was a lack of consistent order execution. So when this organization placed an order, if you imagine a large organization has lots of suppliers, when this order is placed, then, okay, here's the process for doing that. But when I place an order over here, it's a slightly different process. And so that was a challenge. And there was no external enterprise authentication and authorization structure that was available from a single consumable organization API. The solution was to build a continuous data acquisition process that would acquire product master data that was existing within the organization and put it into a structured cloud-native storage system, such as DynamoDB, and then to have a single GraphQL schema to address that data to be able to describe all that data that exists. So what that looks like here is if you can take that GraphQL schema that was generated earlier automatically, now we have the ability to introduce in that single schema a mutation that says, hey, I want to order a product, and I will now have one product order interface for the entire organization, no matter which system that it goes to. I've got a router that can route that properly to the right systems. And by the way, it's using the exact same type system and the exact same ETL transformation that was used before, so it's the exact same structure, but now I've authorized external entities to start surfacing certain parts of that data structure. So from an enterprise organization perspective, this is fantastic. You're probably used to systems where, hey, I'm going to build something internally, now I need to build something externally, I'm going to spin up a whole new team, and I'm going to spin up a whole new way to actually expose that data. By leveraging the power of a single serverless, highly scalable AppSync system, I can take this data transformation that exists within the organization and now start to very selectively expose parts of it to my partner organizations so that they can actually start taking advantage of the data that I have within my organization. Suddenly, the agility, the speed at which I can start to service my partner organization goes up, the quality of the data that I can produce to those organizations goes up, and I have a more consistent interface across the entire enterprise, thus increasing the brand of my organization. So appreciate the time. This was a crazy idea about 2 years ago to actually start trying to use AppSync in this way. We've loved working with Ed and the AppSync team to be able to do this, and we look forward to doing a lot more with them.
Thank you very much, folks. It was a pleasure. I think we have about 5 minutes for questions, if anyone is interested. Yeah, you can
ask a question. We'll just repeat it.
You can ask a question. Yeah, we can answer.
I had a question. AWS Amplify, you're familiar?
Yeah.
Yes. When you create your schema, start creating your schema, I was wondering if you could create arguments for that schema instead of having to go to the console and edit the schema, which will be overrun by pushing on Amplify.
So the question was how to create arguments on the schema and Amplify to push that to the console. What sort of arguments?
Like a subscription argument. If I wanted to subscribe based on a particular user,
Yeah.
I could go to the console and do that. But if I update my schema on Amplify, it'll overwrite that every time. So when creating the schema, creating your models, I was wondering how to make arguments for like subscriptions.
Yeah, with Amplify today, you're right. As soon as you do a push, that's going to overwrite wherever you have. But stay tuned. We have a solution for that problem coming up very soon. Okay. Yeah, I cannot share much, but yeah, we're working on that. We know that that is a known problem. And by the way, if Amplify is open source, right? You can basically, if you have suggestions or issues like that, please open an issue on the Amplify GitHub repository. Our developers who develop the service are actually constantly monitoring the GitHub repository, and they're actually answering the questions and working on feature requests like that.
Any question over here?
Yes?
How does it compare to, let's say, using AWS Glue rather than using a mutation to do your ETL?
So Glue is one type of execution engine that can be used. It's just not limiting it to only Glue and only Spark. So there's a lot of data transformations that do exist through Spark. What we're doing is bringing the abstraction up another level such that you can do a transformation in an ECS task in a Docker container. You can do it within a Lambda function, or you can do it within a Glue-based job. You don't have to just do it in Glue. You have the choice. I think there's a question over here. great question. So
Let's just repeat the question for the folks.
So the question was, how long did it take you to develop that? So we believe in an iterative-based cycle. So started off with a proof of concept. That led to an initial pilot implementation. That led to some expansion of features. That was so successful that it led to, that was kind of like the 1.0 where we got that working. Then the project was funded to really go to like the 2.0 status where we added a lot more capabilities to be able to do that. So I'd say total time frame so far is about 1.5 years for the whole process. We're on 2.0. I'm having just conversations with people who want like 7.0 type features. So we're going to be at this for a while. Question?
I'm just getting introduced to kind of GraphQL concepts and AppSync. It seems like kind of a crazy, kind of exciting service, particularly from the end of being able to subscribe clients to mutations and things happening in your system, kind of like higher level events happening in your system, and kind of see those in real time without having to build any sort of kind of other moving parts to take advantage of that. One thing that has concerned me about AppSync is when digging into it, I've seen a lot of other projects use batching tools to batch requests on the back end. And I'm wondering about, I've seen that AppSync uses limited batching, and I'm concerned that it's going to kind of like start hammering our database, especially when we kind of have deeply nested types of queries. I'm wondering how, in practice, that especially with more sensitive databases, where that is on the roadmap, and how if there are any kind of workarounds to those types of batching N+1 problems, and how that's affected you generally.
So AppSync, will probably introduce capabilities over time to address that. What we specifically did with this data fabric solution, that's why we have the architecture we have, where every single flow of data through the system is through Lambda and SQS. That allowed, because we actually hit this exact problem, is just hammering databases too hard. So that configurability and the flexibility of the framework in general allows us to have knobs to be able to turn to say, you know what, that type of database, that source system, we only want it to be able to hit this much. So when the jobs get split up, it's very clear how we can do that. And we have these knobs to be able to control that, which is fantastic because nothing has to be recoded. And it's generalized across all of the different type of connection types that exist. So sorry, I think I should repeat the question. The question was, how do you not slam a database so that when these queries come in, so that you take down the database? That was the question.
No more questions?
One more question.
Yeah, sure.
So I was in the DynamoDB talk, and you basically said that scan is never a good option. You're just using a whole scan, and usually the resolver, when you have a schema, the list, the list post or list result, it usually does a scan as a resolver. So I was wondering if you still use that, or if you have an alternative.
Yes, so the question is, you've been in a talk, and it was mentioned that scans might not be a good idea. We do have scans in some resolvers, but you can also select to have a query, for instance, right? I think we try to make it simple, where you can query your data on Dynamo, right? We do have the options to do scans where it's in place, or to do queries, and it's up to you. When you build some APIs from scratch, like this one I just created from Dynamo, it does use scans, right? But it's something that you can change on your backend. It's basically a way of making it more generic, but you can change those dials if you need to. Yeah.
One of the solutions that we've used to solve that exact problem, again, the power of AppSync, is that because you have a single schema and you want to get a single object, you can represent that. But if you want to get all objects, that doesn't necessarily have to go to Dynamo. So we actually use the DynamoDB triggers to be able to stream those changes out and then batch those changes into a single S3 object, so that when you actually go to get all, it just pulls a single S3 object. So you're not killing your Dynamo database, and you're not destroying your cost.
No more questions? Well, thank you very much. It was
Thanks
a
for
pleasure.
toughing it through the 5 o'clock.
Yeah, you hang in there. Thank you.